The world we're living right now is slowly getting closer and closer to the sci-fi movies we grew up watching. Remember beaming in Star Trek? Remember full space ability in Star Wars? Yep. Teleportation. Crazy, right? It's kinda possible now. Quantum teleportation, basically the teleportation of information at a quantum level. This information is known as quantum information or qubit. These can be polarity, spins, or even zeros and ones. Breakthroughs in quantum teleportation has come thus far. Photon teleportation through computer chips, long-distance teleportation of time-being qubits, 4 to 4 kilometer qubit teleportation, all without a physical link. The list would go on and on narrating what has happened, but let's talk about why this happens. Quantum teleportation is made possible by this weird phenomenon called quantum entanglement. Think about two particles, no physical connection in between, but these two are entangled. In this state, if the property of the first particle were measured, the property of the second particle could be predicted without measuring it. This telepathic twinning between particles can stretch across space and time. Spooky action at a distance. Einstein says so. So how does this relate to quantum teleportation? Let's assume a source that produces two entangled particles A and B. In experiments, this is called an EPR source. Two kids, Anna and Ben, shares this entangled pair of particles A and B. Anna wants to send information to the particle Ben has. This info is embedded in a message particle. In the quantum world, particles are in superposition.
Once we observe a particle, it undergoes a change or collapsive state,
somehow disturbing it.
So how do we determine the possible states of particle M and A without them collapsing from their superposition state?
This is where the Bell state measurement comes in. We can indirectly observe the states of particles and only partially breaking superposition. When made to interact through a Bell state measurement, particles M and A becomes partially entangled. By classical communications, Anna tells Ben the outcomes. He can then use this information to interpret what the original message particle is.
That was a successful teleportation.
We're able to send quantum information without physically transporting it. You see, quantum teleportation has opened doors for more amazing technologies. This is the future of data security and data processing. Who knows what else? Well, teleportation sure is half wonderful and half weird.